If you open your Chrome browser right now and imagine running a full Linux operating system directly inside it without installing anything, without partitioning your hard drive, and without worrying about breaking your current system, that idea might sound almost unreal. For years, running Linux meant downloading ISO files, creating bootable USB drives, setting up virtual machines, or replacing your current operating system entirely. But today, things have changed dramatically. Thanks to powerful cloud computing platforms and browser-based virtual environments, you can launch a complete Linux desktop right inside Chrome with just a few clicks. No installation, no complicated setup, and no risk to your existing system. In this video, we're going to explore how you can run full Linux distributions in Chrome using the best no-install cloud environments available today, why these platforms exist, how they work behind the scenes, and which ones are actually worth using for developers, students, and tech enthusiasts. The first thing to understand is how technology evolved to make this possible. Traditionally, operating systems run directly on your hardware. Linux distributions like Ubuntu, Debian, Fedora, or Arch need access to your CPU, memory, storage, and graphics hardware. But with the rise of cloud computing and virtualization, companies started hosting powerful servers that could run operating systems remotely while allowing users to access them through web interfaces. Essentially, instead of Linux running on your laptop, it runs on a remote machine in a data center somewhere in the world. Your browser simply becomes the window that connects you to that remote system. Modern browsers like Google Chrome are incredibly powerful applications. They support advanced technologies such as WebAssembly, WebSockets, containerized environments, and high-performance JavaScript engines. These technologies allow complex applications to run smoothly inside the browser, including full development environments and graphical Linux desktops. Because of this, developers started building platforms where users could launch Linux environments instantly through a web page. One of the biggest advantages of running Linux in the browser is accessibility. Anyone with a device that has Chrome installed can use these environments. It doesn't matter if you're on Windows, Mac OS, Chrome OS, or even a tablet. As long as you have internet access, you can open a tab and start working with Linux immediately. This removes the traditional barriers that many beginners face when trying to learn Linux. Another major benefit is safety. Installing Linux locally sometimes involves disk partitioning or modifying system bootloaders. For beginners, that process can be intimidating and risky, but browser-based Linux environments eliminate that problem entirely. Since the operating system runs remotely, nothing on your computer changes. If something breaks inside the Linux environment, you simply refresh the page or restart the container. These cloud Linux environments are also extremely convenient for developers. Software development often requires complex tool chains, package managers, and system dependencies. Setting up a development environment locally can take hours or even days, but cloud environments provide pre-configured Linux systems with many tools already installed. Developers can instantly access terminals, code editors, compilers, and package managers without spending time on configuration. One of the most well-known platforms for running Linux in the browser is GitHub. GitHub designed code spaces to give developers instant development environments that run in the cloud. When you launch a code space, GitHub creates a containerized Linux system on a remote server and connects it to your browser using a web-based version of Visual Studio Code. Inside this environment, you get a full Linux terminal, access to programming languages, debugging tools, and direct integration with GitHub repositories. What makes Codespaces powerful is its ability to reproduce development environments. Exactly. Developers can define configuration files that describe the packages, dependencies, and system setup required for a project. When someone launches the Codespace, the environment automatically installs everything needed. This ensures that every developer working on the project has the same setup. Another impressive cloud Linux environment is Git. Gitpod works similarly to Codespaces but focuses heavily on automation and developer work. With Gitpod, you can launch a Linux development workspace directly from the Git repository. The platform reads configuration files that define how the environment should be built, installs all dependencies, and opens a browser-based editor connected to the Linux container. Inside Gitpod, you get access to a terminal running a full Linux system. You can run commands like apt, install software packages, compile programs, run servers, and perform nearly everything you would normally do in a local Linux machine. The difference is that everything happens remotely while your browser acts as the interface. Another platform that demonstrates the power of browser-based Linux is Replit. Replit started as a simple online coding platform but evolved into a full development environment with Linux containers behind the scenes. When you create a project on Replit, The system automatically launches a Linux container where your code runs. You can open a shell, install packages, run scripts, and build applications. What makes Replay particularly interesting is how beginner-friendly it is. Students learning programming can instantly start writing code without installing compilers or development tools. The Linux environment is already prepared and accessible through the browser interface. There are also platforms designed specifically for learning Linux itself. One of these is Play with Docker Labs. This environment allows users to run Linux containers inside a browser and experiment with Docker commands. It creates temporary virtual machines that users can access through web terminals. Although the machines only exist for a limited time, they are perfect for learning containerization and Linux command line operations. Another fascinating example is WebVM, a project that runs a lightweight Linux system entirely inside the browser using Weebus. Unlike cloud-hosted environments where Linux runs on remote servers, WebVM actually emulates Linux directly in your browser tab. This means the operating system runs locally using browser technologies without requiring external servers. WebVM demonstrates how powerful modern browsers have become. By compiling Linux components into web, developers created an environment where the kernel and user space applications can run within the browser sandbox. The result is a small Linux distribution that launches instantly and works offline after loading. However, browser-emulated Linux environments usually have limitations compared to cloud-hosted ones. Performance may be slower, persistent storage might be limited, and heavy workloads are not ideal. But for educational purposes and quick experiments, they are incredibly impressive. Cloud-hosted Linux environments generally rely on container technology. Containers allow multiple isolated systems to run on the same physical server while sharing the underlying kernel. Tools like Docker and Kubernetes manage these containers efficiently, enabling platforms to create and destroy environments quickly for each user. When you launch a browser-based Linux workspace, the platform typically performs several steps behind the scenes. First, it allocates a container or virtual machine on a server. Then it installs the necessary operating system files and development tools defined in the configuration. After that, it establishes a secure connection between your browser and the remote system. Finally, it streams the terminal or graphical interface to your browser window. The communication between your browser and the remote Linux environment usually happens through secure protocols such as WebSockets or SP. These technologies allow real-time interaction. So when you type commands in the browser terminal, they execute immediately on the remote system. Many of these platforms also support graphical Linux desktops through browser streaming technologies. Instead of just showing a terminal, they can display full desktop interfaces such as XFCE or LXDE. This means you can open file managers, text editors, and graphical applications directly inside your browser tab. Another advantage of cloud Linux environments is scalability. If you need more computing power for compiling code or running large workloads, the platform can allocate stronger servers automatically. This is something that local machines cannot always provide easily. For developers working in teams, browser-based Linux environments also improve collaboration. Team members can share environment configurations and start working on projects instantly without worrying about inconsistent setups. Some platforms even allow real-time collaboration where multiple users edit code simultaneously in the same environment. Education is another area where browser-based Linux environments have become extremely valuable. Many schools and training programs use these platforms to teach programming, system administration, and DevOps skills. Instead of requiring students to install complex software on their personal computers, instructors simply provide a link to a cloud environment. Students open the link in Chrome and immediately get access to a Linux terminal ready for practice. This approach eliminates technical setup problems that often waste valuable class time. Another interesting benefit is portability. Because everything runs in the cloud, your Linux environment follows you everywhere. You can start coding on your desktop computer, continue working on your laptop, and later access the same environment from a tablet or even a smartphone browser. Persistent storage is also supported by many platforms. This means your files remain saved even after closing the browser. The next time you open the environment, your projects and settings are still there exactly as you left them. Security is also an important consideration. Cloud platforms isolate each user environment using containers or virtual machines. This isolation prevents one user from accessing another user's data and protects the host system from malicious actions inside containers. Of course, running Linux in the browser is not perfect for every situation. Internet connectivity is required for most cloud-based environments. If your connection is slow or unstable, performance may suffer. Additionally, some heavy applications like GPU-intensive programs or large-scale data processing may not run efficiently in browser-based systems. Despite these limitations, the technology continues to improve rapidly. Faster internet connections, improved container orchestration, and more powerful data centers make cloud Linux environments increasingly capable. In recent years, we have also seen the rise of browser-integrated development environments that combine code editors, terminals, debugging tools, and cloud execution into one interface. These platforms blur the line between local software and cloud computing. Another interesting trend is integration with artificial intelligence tools that assist developers directly inside these environments. AI-powered code suggestions, automated testing, and intelligent debugging features are becoming standard components of modern cloud development platforms. The combination of cloud Linux environments and AI assistance could significantly change how software development works in the future. Developers might spend less time configuring systems and more time focusing on building actual applications. For beginners who want to learn Linux, browser-based environments provide the perfect starting point. They allow experimentation without fear of breaking the operating system. Users can explore commands, install packages, and understand how Linux works without making permanent changes to their computers. Even experienced system administrators sometimes use these platforms for quick testing. Instead of spinning up full virtual machines locally, they can launch temporary Linux environments in seconds and run experiments. The idea of running operating systems through browsers may seem futuristic, but it reflects a broader shift in computing. More applications are moving from local installations to cloud-hosted services accessible through the web, email, document editing, video editing, and even game streaming now operate through browsers. Operating systems themselves are slowly becoming services delivered through the cloud. Browser-based Linux environments represent one of the clearest examples of this transformation. As technology continues to evolve, we can expect even more powerful browser-based computing experiences. Faster web standards, better virtualization technologies, and stronger cloud infrastructure will allow full desktop environments to run seamlessly inside browsers. One day, it might become normal to launch entire workstations through a web browser without installing anything locally. For many users, especially developers and students, that future is already starting to arrive. Running full Linux distributions in Chrome without installation is no longer just an experimental idea. It is a practical solution used by developers, educators, and technology enthusiasts around the world. With platforms like GitHub Codespaces, Gitpod Replit, and browser-based projects like WebVM, accessing Linux has never been easier. If you have never tried one of these environments before, it is definitely worth exploring. Open Chrome, search for one of these platforms, launch a workspace, and within seconds you will be interacting with a real Linux system running somewhere in the cloud or even directly in your browser. This shift toward cloud-based computing shows how flexible and powerful modern technology has become. The operating system is no longer tied to a specific machine. Instead, it can live anywhere and be accessed from any device with a browser. For developers, learners, and curious tech users, that opens up incredible possibilities. The barrier to entry for experimenting with Linux has almost completely disappeared, and the only thing required to get started is a simple Chrome tab and an internet connection.